In this particular application of CFD modeling, we used it to predict and mitigate smoke concentrations in a casino. The casino, shown here in the top view, was broken up into a variety of sections. We created these sections because it's a very large facility with tall ceilings. So we broke it up into sections so that we could analyze each section. The sections are all connected to one another through air flow, so the air is able to travel from one section to another. But we did break it up into sections just to keep the model reasonable in terms of size. This is a surface mesh of the entire facility. You can see here we're showing just a few of the sections, 3 of them. It's kind of a pretty shot, but these are surface meshes. This has a dome out on this edge of the casino, and these are big gaming areas in here. This is a very tall ceiling with coffer in it, so it goes deep. Another section over here. These are all gaming sections. The problem in this casino was ventilation. The design of the original ventilation was done in a way that was causing smoke to rise up into the top of these ceilings and condense, and tar would fall out of the air and land in the casino and on the people as well. Another shot of some of the detail of the mesh that we created for the different sections. Another one here of the other sections. We then added in all of the supplies, and according to the CAD drawings or the design drawings for the environment, they were again segmented into 10 groups, and each one of the sections got its own number of diffusers and quantity and appropriate flow rates with air change rates. Same on the return vents. We put them all in according to the representation in the CAD drawings that were done for this site, and so you can see it's a little hard to see here, but you can see all of the returns put in place. We then modeled the amount of smoke. We did this by looking at typical smoke coming out of a smoker, and then we populated the room with smoke emissions. These are emitters that we put in the room. We calculated the amount of emission that was going to be done by each of the people, and we put it into the model. So these are sources of smoke, and we quantified it based on literature and added it to the environment so that we could distribute the heat and smoke throughout the entire casino uniformly. And then watch it flow. This is a shot from the top looking down at the casino at a slice of 5 feet. And you can see here, based on the way that the diffusers are set and the flow is set, that there is a movement of air through a section of the building, set of doors here that connect this section to this section, and there's air actually moving at a fairly high velocity from one section to another. And then you see these eddies, these currents, vortices, small vortices in the room, quite a few of them. This is where smoke will accumulate and get pretty thick because that's a low pressure area in the center, and that'll cause accumulation of density, smoke density, and that will cause issues. It's a little better over here. This is a better representation because the eddies are smaller and they're more distributed. But here you've got a couple of big ones, and that's going to cause issues. So the question, now that we understand how the flow occurs, is what can be done to prevent it. This is another shot of it coming out of that one section into the center of the gaming area, causing issues. These are slices. We're just looking at slices. You can see in the background the 3D CAD, and we've superimposed slices of CFD results into those sections. You can see some issues with buildup of smoke in these areas. This is a velocity plot. We're looking at air velocity because the velocity will tell you where the accumulation is going to occur. This is smoke density. Here we're looking at smoke particles in parts per million. We, as I told you earlier, injected smoke into the environment, and then we're able to, with air velocity, track the smoke throughout the environment. You can see that's pretty good over here. At 5 feet we don't have too much smoke problems here, we've got a high density of smoke over in this area. Poor ventilation is there and needs to be solved. Another set of smoke. Smoke is coming in, as we mentioned earlier, coming into this main section where it's going to accumulate and cause issues. Vertical sections, again, smoke density. As you go up, you see the smoke density high here. That combined with temperature will cause condensation, and that will create the tar from falling out of the air and onto the people below it. Temperature profile here at 15 feet. Heat load due to the machines in the room. We actually modeled the heat load coming off of those gaming machines and put that into the room as a heat load, as well as the people. Temperature profile here. So once we had this all set in place, we were able to then make modifications to the overall design to mitigate smoke, reduce it, and get it out of that gaming area. And the model was used as a way to both prove what was there, validate it through inspection, and then once the model is created, you can modify it to a new design, a different design, where you can mitigate the smoke. In this case, what we did is we inserted fresh air down low into the building and turned everything up at the ceiling into returns, and so we essentially built a bottom to top kind of airflow where all of the air would go up and out. No supplies at the top, and that was part of the problem they had in this design. Thank you.